Okay, so it's asking us to find the indicated sum of the arithmetic series. So as soon as I do that, I'm going to write the formula. First guy, last guy. Okay, so they want the sum of the first 18 terms. So 18 is my n. So I'm going to go 18 over 2. The first guy, 6. And then I need to get the 18th term. So if I'm going to get the 18th term, use the formula for the arithmetic sequence. Sorry about that. First guy, I want the 18th term, and the pattern is positive 2. 17 times 2, 34, plus 6 is 40. So let me put that there, 40, and that 40 is going to go right there. Okay. And then I'm going to pick up my calculator. 18 divided by 2 is 9. 9 times 46. And that's 414. Okay? So the sum of the first 18 numbers is 414. Make sure, sorry, let me make that more clear, that you're saying the sum of the first 18 numbers. All right. I'm also asking you to find the sum of this series, but this time it's in summation notation. The difference between this one and this one is, here you have a list of numbers and the first term came right away. You don't have the formula, but here you have the formula, but you don't have the first term, just like that. Either way, you're going to use the same exact formula to find the sum. This time they want the first 20 numbers. So I'm going to go 20 parentheses and then over 2. Now to get the first term, I'm going to have to plug 1 in for my k. So I'm going to go 59 minus 4 times 1, 59 minus 4, and that's 55. So that 55 will be my first term. And then I need to get the 20th term. So to get the 20th term, I'm this time going to plug in 20 in for k. So 59 minus 4 times 20, 59 minus 80, 21 negative. So now that is minus 21. And then in my calculator, I'm going to, let's make sure I did that right. 59 minus 4. Good, let's see. 4 times 20, 80, perfect. Okay. So then what I'm going to do is I'm going to go 55 minus 21 is 34. And then 20 divided by 2 is 10, and that's 340. So the sum of the first 20 numbers is 340. Okay. All right. Now let's go to this one. I want to know if it's arithmetic or geometric. So it's dividing by 4, negative 4, which is really multiplying by negative 1/4. So it's geometric. Find the ratio. The ratio equals negative 1/4. And then just for good measure, I'm going to write down the formula in case I ask for it. So that's the geometric formula. First guy, the ratio is negative 1/4 to the n minus 1. So if I ask you for the formula, that's the formula for the geometric sequence. Find the 10th term of the geometric sequence. So I'm going to use the same formula here, and I'm going to apply it there. So I'm going to do this first term times the pattern to the n minus 1. There is the formula. Now to find the 10th term of the sequence, I'm going to take my 10. I'm going to plug it in, show my work, pick up my calculator. So I'm going to go 3 to the 9th times 6. I get 118. So that means the 10th term, it's not the sum, so it's a sub 10 equals 118098. Okay, so be clear about that. When I'm saying the sum, you're going to put an S, but when I'm asking for the actual 10th term, you're just putting an A. All right, find the 7th term of the geometric sequence. The problem is, okay, so let me write down the formula. AN equals A1, R to the n minus 1, same thing. But the problem is I don't have a first term, so I've got to pretend that this is my first term. If I want to pretend with this one, I have to pretend with this one. This was 2 back, so this is 2 back, and I have to pretend with this one, that one's 2 back. So now I'm going to take my first term, plug it in there. I don't know my ratio. If I knew my ratio, remember, life would be a lot easier. So I'm going to take my 4, that goes in for n, and I'm going to take my 320, and that goes in for a sub n. So I go 320 equals 5r to the 4 minus 1, divide by 5. 64 equals r cubed, cube root. So I get my ratio, which is 4. Now that I have my ratio, I'm going to find my fake fifth term, which is really my 7th term. So I'm going to go a sub 5 using this formula for fake first guy. The ratio now we know is 4, and it's the fake fifth one to the 5 minus 1. So now I'm going to pick up my calculator, and I'm going to go 4 to the 4th, and we'll multiply by 5, and I get 1280. Now remember, it's not really my fifth term, so my 7th term is 1280. Okay. All right. I want you to find the sum of the geometric series. There's 2 formulas for the sum. There's a simplistic one and there's the fancier one. The simplistic one is when it's infinity, so it's only to 8. So I'm going to use the fancy one. So I know it's a sub 1 minus r. That's the simplistic one if that's at infinity. Okay? And then it's 1 minus r to the n. Now I want to address, if this same problem said infinity, it would diverge, there is no sum, because the ratio is greater than 1. But if this same thing said 1/9, then it converges, you can do it, and you would use this simplistic formula. But since it does have a limit, let's actually just plug it in. So to find my a sub 1, I plug in 1, or you know that since it's set up like a geometric series, that 6 is my first term. But just to prove it to you, I'll show 1 minus 1. 1 minus 1 is 0. Anything to the 0 is 1 times 6 is 6. So that's my a sub 1. My ratio is 9. And I'm asking for the sum of the first 8 numbers. So there we go, right there. Okay, so sorry, that's going to be it right there. Now I'll show my work. 6 parenthesis 1 minus 9 to the 8th power over 1 minus 9. Now for me, using this calculator is kind of annoying, but you can, of course. I would rather use this calculator. Turn it on here. So I'm going to go control divide. 1 minus 9 to the 8th. Now I would be careful and I would put it in parentheses, just because if that 9 was negative and you didn't put it in parentheses, you would get a different answer. Okay? All right. And then 1 minus 9 is negative 8. And it gives me a really big answer, which makes sense because the ratio is huge. So it looks like 3, 2, 2, 8, 5, 0, 4, 0. And that's the sum of the first 8 numbers. Okay? So all I want to know if it converges or diverges. You got a 50% shot. So if I look here, it's dividing by 3, which means the ratio is 1/3. Since the ratio is less than 1, I can do it. It converges. Okay? This is what I want to see for your test. Okay? This one is times 2 times 2. So that means the ratio is 2. Since the ratio is greater than 1, I cannot do it if it is an infinite sequence. So it would be that it diverges. Okay. All right. It says if it exists. So it's infinity, but the ratio is less than 1. I can find the sum. If it said 30 parentheses 5 to the k, the answer would be you couldn't. A to the 1, 1 minus r, simplistic one. A to the 1 means I'm going to go 30, 1/5 to the first power to find the first term. 1/5 to the first is 1/5 times 30 is 6. So my a sub 1 is 6, and my ratio is 1/5. So I'm going to go 6 divided by 1 minus 1/5. 1 minus 1/5, you can use your calculator, of course, is 4/5. 6 divided by 4/5 is the same thing as 6 times 5/4. 3 halves, 15 halves. The sum of the infinite numbers of this sequence is 15 halves. And there's the review.